Alright everyone, how are we doing? Today we are going to be looking at the Pythagorean Theorem, which most of us are probably familiar with, but we're going to take some time to look at it anyway. Now, as you know, the Pythagorean Theorem deals with right triangles, which is continuing with the unit that we've been dealing with. So, let's assume that this triangle I am drawing here is drawn to scale, which I know we all know is a dangerous assumption with Mr. Berger. Okay, let's label that leg A and this leg B, and then the hypotenuse will be C. Okay, now the Pythagorean theorem simply states that when you have a right triangle with legs A and B and hypotenuse C, we can find that A squared plus B squared equals C squared. Pretty simple stuff. Take a moment to get that down, and then, as we always do, we will begin on a proof of this theorem. Okay, so let's look at the proof now. Okay. First things first, we need to look at a little square, okay? Alright. Now, again, this is just me drawing this to the best of my abilities, and not necessarily perfectly to scale, but honestly I think I did a pretty good job considering. Okay, so in our diagram here we're going to find that we have four triangles, as you see, and we're going to label each one of these A. The small sides are A. Okay, and the larger sides are B. Inside here, each hypotenuse of the smaller triangle is going to be C, and then of course we need to make sure that we have our symbols in here so that we are certain we are dealing with right triangles after all. Okay, so essentially what we're going to do is we're going to use this setup to show that our C squared, the inside here, is equal to A squared plus B squared. Okay. Now I'm going to, just a moment here. Now how we're going to do that is we're going to show that each triangle, we know that the area of this total square is going to be the area of each triangle, which they are identical, added to the area of this inner square here. Okay, so I'm going to do that by setting up an equation that says 4 times, okay, and then our formula for area of a triangle is 1/2 base times height. So each of these have a base or height, it doesn't matter, of A, and the other is B. Okay, so 4 of those plus this inner C squared area is going to be equal to our A plus B side lengths squared. Okay, and that is where we're going to work from now. Okay, so now we'll continue with this. First things first, we need to expand the left side and then expand the right side of the equation. So over here on the left side we have 4 in the numerator and 2 in the denominator are going to cancel out and leave us with 2AB plus C squared. Okay, and that's basically simplified on the left side for now. Over here on the right side of our equation we're going to expand out our binomial, which is going to give us A squared plus 2AB, if I can write, plus B squared. Okay, now as you can see we have a common term on both sides here, 2AB. So what we're going to do is we're just going to simply subtract that term from each side. So minus 2AB minus 2AB, okay, Anything we do to one side of an equation we do to the other, so it's canceled out now. And we are left on the left side of our equation with c squared is equal to a squared plus b squared. And therefore, we now can say we have proven the Pythagorean theorem.